Okay, in this problem, we're asked again to use what we know about the unit circle to help us through some composite trig functions. And, I mean, right away, you can see these are not nice angles. It's not like 90 degrees, 30 degrees, 45 degrees, something like that. You got ugly angles here, and we're told to figure out what's the inverse sine of the sine of 118 degrees. Okay, so I'll start with this one first. 118 degrees is, I don't know, right there. And that's not right. Come here. Okay, there we go. So there's 118 degrees. And the sine value of 118 degrees is right here. Geometrically, it's represented this way. Sine of 118 degrees. Okay, there it is. It's the y-coordinate. Now, I don't know what the y-coordinate is. It's going to be some crazy decimal, like 0.9 or something. Okay? It's not important. We're asked to figure out what the inverse sine of that y-coordinate is. In other words, what angle was required to produce that sine value. And at first you may look at this like, oh, come on, it's 118 degrees. It's literally what we started with. Well, not quite, because you have to remember for this problem, let me clean this up a little bit. You have to remember for this one that the sine values, the inverse sine values are restricted to quadrant 1. Okay, that's where inverse sine lives. So what angle in quadrant 1 gives us an equivalent value for the y-coordinate? Okay, that's what this question is asking. So here's how to think about it. Let me just clean this up. I'm going to draw a triangle. Here's my triangle. And it's exactly the same triangle as the one in red. It's just flipped over. And I'm asking you, what is this angle right here? Okay, what is that angle? Because it's not 118 degrees. Okay, that was the first one. So what is this angle? Well, if you imagine that blue angle right there, that's going to be basically the same thing as this angle on the left, right? They're similar triangles. So those angles have to be the same. Well, what's that angle? If I have 118 degrees over here, right, 118 degrees, I should be able to figure out what that blue dotted angle is inside the red triangle. Okay, I'll pause. Well, you should pause the video here and try to do it for yourself. But just in my head, I'm thinking, okay, well, 180 degrees, I'll call that x, equals x plus 118 degrees. So that means x equals, math, 62 degrees? 62 degrees. Okay, x equals 62 degrees. That's that blue angle. And therefore, that is this angle right here on the right. That's the quadrant 1 angle that produces the same value as sine of 118 degrees. Okay, 62 degrees. The point of this problem is recognizing the symmetries in the unit circle and how those flip back and forth in this picture. And you can do the same exact thing for the cosine. Okay, let me, oh boy, I got a lot of stuff to erase here. Cosine function. Erase. There we go. So for the cosine function of 209 degrees, you think about where 209 degrees is. Okay, that's an important first step. 209 degrees. Let's see. Well, it's past 180, so I'm just going to call it over here. Okay, there's 209 degrees. Well, what is the value? What is the angle in quadrants 1 or 2? Remember, cosines are limited to these quadrants right here, or inverse cosines, I should say. What is the angle in those two quadrants that has the same x value? Okay, and I'll just use purple for this guy. Well, the same x value is right here on the unit circle. So the question we're asking is, what is that angle in purple? And you can figure that out by a similar method. If 209 degrees is in orange, then this angle right here, this little guy, is going to be 209 minus 180. Okay, and try to visualize this as a big pizza and see if you can help yourself understand from that point of view. Or you have no idea what I'm talking about. I don't know. So this is 29 degrees, that little angle right there, which means this is going to be 29 degrees also. Okay, so if that's 29 degrees, this portion right here, well, what's the angle over here? That's going to be 180 minus 29 degrees. Okay, so that is, more math, 151 degrees, 151 or so. There we go.